Morning. Welcome you all for the next session. So in this session, we are going to discuss about the Kirchhoff laws. So we know that there are two laws are there. One is Kirchhoff voltage law and Kirchhoff current law. So before going to see the Kirchhoff laws in depth, we have to recall the previous classes what we are discussed in the previous class. I think we all discussed in the DC circuit. So DC circuit consists of components. So the components were discussed. I think conductor, resistor, inductor, and capacitor. And what is a conductor? It allows the electrons to flow. And what a resistor? Resistor resists the current, and its unit is ohm. And also for the inductor is a stores the energy in the magnetic form, and it is unit is Henry, and capacitor also it stores energy, and unit is Farad. So I think all the informations in depth we are discussed in the last class, and we have to keep in your mind what are the components we are using in the DC circuit is CRLC. So conductor, resistor, inductor, that is CRIC, that is conductor, resistor, inductor, and then capacitor. So next we have to see what are the topic we are going to discuss under Kirchhoff law. First, we have to see the fundamentals and the current law, voltage law, and then application of the analysis and how it is related with the real world example, right? So let's explore our Kirchhoff laws. So first, we have to discuss about the KCL, which is Kirchhoff laws found out by Gustav Kirchhoff, that is in 1848. I'm sorry, 1845. So based on the conversation, the charges and the energy, right? What is the importance of Kirchhoff law? Already we are studied about Ohm's law. So what is the importance of Kirchhoff law? It is Ohm's law applicable only for the simple circuits, that is simple DC circuits, and so it is not applicable for the DC, complex circuit. So based on that, the Kirchhoff found the laws for the complex DC circuit, right? So here I have uh, there are two pictures are there. One is the Kirchhoff current law and one is the Kirchhoff voltage law. And first we have to see the current law. So what is the statement of Kirchhoff current law? Yes, we have to say in two ways. One is entering current equal to leaving current, right? Or at any node, the sum of currents entering equal to the sum of leaving. That is summation of I in is equal to summation of I out. So here I have to mention a picture. There are I1, I2, and I6 are entering into the node, and I3, I4, and I5 are leaving from the node. So we have to write the equation I1 plus I2 plus I6, which is equal to I3 plus I4 is equal to plus I5. And next one is KVL, that is Kirchhoff voltage law. The statement states that the algebraic sum of all potential differences around any closed loop in a circuit is 0. So here there is a loop is there. So we have to write the equation, that is voltage source is equal to the drop in the resistor B, C, D, E, and the F, which is equal to 0. So here I mentioned that is V source minus VR1 minus VR2 is equal to 0. Like this we have to write how many resistors are there. So along with this we have to write, and along with the source, which is equal to 0. And there is a loop rule is there to write the equation. Here I have mentioned two resistors and two batteries. So first one is from current direction as A to B, we have to write minus I into R. If the current direction is B to A, that is direction level, here mentioned direction travel is B to A, we have to write I into R. Likewise for the battery, that is here I am mentioning first A is connected with the negative and B is connected with positive. So we have to write V. And for the fourth image is node A is connected to the negative and B is connected to the positive. The current flow is in this opposite direction, so we have to write the minus V. So based on this rule only, we are writing the equation for the Kirchhoff laws, right? So empathy of the Kirchhoff law, I think we are know that data-based classroom we are using. So first we have to discuss what is the empathy of the particular topic. So here we are discussing Kirchhoff law. So what is empathy? So first we have to empathy is to find the solution for the any problem. So based on this, the empathy will be designed here. And for the design, that is DT defined for the Kirchhoff law. We are defined as it is normally Kirchhoff laws as fundamental of physics. So based on the problem we are analyzing and analyze with the DC circuit, and we have to uh, fix the problem, and it is called as a define. And next one is the applications. So electronics designs, power systems, mesh node, and also we have the result limitations assume lumped circuits, and we are using for the high frequency or non-linear circuits. And advanced superposition theorem and integration software simulations, and also for the empathetic example designing a home lighting system using KCL and KVL. And here I have mentioned the picture, that is entering the water, and it is living through the three ways. That is the Kirchhoff current law example, and the Kirchhoff rule experiment is here. This picture shows the rules of experiment and the summarization. So what are the points we have discussed in the summarization areas? So important fundamentals and the history of basic laws, and KVL and KCL, and how we can write the equation, applications of solving circuit step by step, and for the real world example. So all those things we have discussed in this session. If you have any doubt, you will ask me. And here I have mentioned a few references also. Thank you all.